welcome to part 2. So just a quick reminder of the very basics of making a letter the subject of an equation. So in this case, we've got to make y the subject. So you know how to do this. We start off by saying 3y equals 12 minus 2x, just the same way as we might solve an equation. I want to get y on its own on the left-hand side, everything else to the right-hand side. Now divide the left and right of the equation by 3. So 12 minus 2x over 3. And what I want you to get used to doing, because it's particularly helpful when we're talking about straight lines, is just split that up. That's going to be the same as 12 over 3 minus 2 over 3x. Okay? That's just working with the rules of fractions backwards. And so y is equal to 4 minus 2/3 x. That's a useful skill because you might get asked a question, for example, here is a straight line equation. What is the gradient of that equation? Well, you would know you have to rearrange that to make y the subject, and then the coefficient of x is your gradient. So the gradient of this line would be minus 2/3. Okay, so please make sure you understand how I've gone from here to here and then to here. Okay, if you don't understand, then ask me. Okay, and the next one's very, very easy. X equals 5 minus cy. So let's take the cy over to the right hand side and the x over to the left hand side. Okay, so that's my first step. Now divide both sides by c. Y is equal to 5 minus x over c. Depending on what you're doing, that could be the answer. Or you might even say it's this, 5 over c minus x over c. Again, splitting up the fraction. It really depends on what you're doing, what the best form is, okay? But that should be easy, but of course do let me know if there's any problems. I also think you should be quite good at this stuff by now as well. So s is equal to a half gt squared. Make t the subject of the formula. So let's just write it down. It's equal to a half gt squared. Well, the first thing I'm going to want to do is I'm going to want to divide both sides by a half g. Now, dividing by a half is the same as timesing by 2. So perhaps a better way of actually understanding that is if I rewrite this like this. S is equal to gt squared over 2. That would be the same thing. That might be clearer to you, so let's do it that way. So then what I'm going to do is just times both sides of the equation by 2. So 2s is equal to gt squared. Then what I'm going to do is I'm going to divide both sides of the equation by g. And so I get t squared is equal to 2s over g. Now, how do I get rid of the squared? Because t is not the subject yet. Well, opposite of squaring is square rooting. So the square root of ts over g. And you probably wondered why did it tell me this, given that t is greater than 0? Well, remember that the square root of anything can be either a positive or a negative answer. So all it's saying is take the positive answer. It's kind of irrelevant for the question. Similar process for the second one. Okay, t is equal to a over root x. Well, let's take the x out of the denominator first of all by timesing both sides by root x. So I get t root x equals a. Now divide both sides by t. And so I get root x equals a over t. How do I get rid of the square root? I square both sides of the equation. So I'm going to get x is equal to a over t squared, which would be the same as a squared over t squared. Either answer would be acceptable. Okay? This is the stuff that's A and A star material. Okay? Again, I've done this with you before, so you might already know how to do it, but definitely need to go over it again because it's the top grade stuff. Okay? So we've got to make x the subject here. Now, when we do this, what we've got to make sure is we get x's onto one side and everything else over to the other side. Okay? So I'm going to try and get this minus bx. I'm going to take away a minus bx, and I'm going to minus a 3, minus a 3. So I'm doing the same thing to both sides. And now I can rewrite that as ax minus bx equals d minus 3. And this is the point at which a lot of students get stuck, okay? They start to do all kinds of crazy things like divide by x or add an x, I don't, Lord knows what they're thinking. But the key is that you need to factorise the left-hand side. So if I factorise ax minus bx, I can take out an x. And now that's neat because what I can do is I can divide both sides by a minus b. If I divide both sides by a minus b, I'll end up with x is equal to d minus 3 over a minus b. And there's your solution. Okay, x is now the subject. Here's another example. Okay, t is equal to a over x minus b. Again, x is in the denominator, so get it out of the denominator by timesing both sides by x minus b. And use brackets. So we're going to get x minus b times t is equal to a. Now expand the brackets. tx minus bt equals a. So we can now throw over the minus bt by adding it. And so tx equals a plus bt. And finally divide by t. So the answer is going to be x equals a plus bt over t. You could even rewrite that if you understood what I was saying about working backwards with the fractions. That would be a over t plus b. Would be another way of writing the same answer. Okay. Last one then. Make x a subject. Y is equal to 3x plus 2 over x minus 1. Again, get that x minus 1, get that x that's in the denominator out of that denominator. Okay, so times both sides by x minus 1. And we will get y times x minus 1 equals 3x plus 2. Now expand the brackets. So get yx minus y equals 3x plus 2. Then get anything that has an x in it over to the left-hand side and everything else over to the right-hand side. So the way to do that is take 3x from both sides and add y to both sides. So I get yx minus 3x equals y plus 2. Now factorise the left-hand side. X times y minus 3 equals y plus 2. And so x is equal to y plus 2 over y minus 3. Okay, I hope that's clear. Anything that's misunderstood, just let me know. Here are 8 questions for you to have a go at. Okay, and stop the video and have a go. We'll show you the answers after you've done it. Okay, hopefully you did it. So make r the subject. So you're going to get r squared equals a over pi. So r is equal to the square root of a over pi. Simple. Okay. Times both sides of the equation by 5. You're going to get 5t equals the square root of L. So square both sides, then L is going to be 5t squared. Don't forget to square everything. So L is equal to 25t. Okay. C, get everything with an x over to the left-hand side and everything else over to the right-hand side. So I'm going to get mx minus nx is equal to minus a minus 2. Factor out the x. X times m minus n equals minus a minus 2. So x equals negative a minus 2 over m minus n. You may have got a different answer. If you've got this answer, x equals a plus 2 over n minus m. That's actually the same answer. Hopefully you can see why. If you're unclear, let me know. Okay. Same with D. Maybe this will clear up why the other one had the same answer. This time I'm going to do something slightly different. I'm going to take away 8x from both sides. So I'm going to get a is equal to minus bx minus 8x. Okay, factor out the x. Okay, so x is equal to a over negative b minus 8. Which actually is the same thing as negative a over b plus 8. Okay. Okay, part E. Make y the subject. So I need to get y out the denominator. So I'm going to say m times x squared plus y squared equals 4. Expand. Mx squared plus my squared equals 4. Okay, my squared equals 4 minus mx squared. And finally divide everything by m. 4 minus mx squared over m. And then square root everything. Tricky question. 4 minus mx squared over m is a solution to E. Just going to delete everything so I've got spaces. Okay, I'm going to do this one up here. So I'm going to first of all get x out the denominator. Okay, expand 3y minus 2xy equals 3x plus 7. Okay. Get x. X is on the same side, so I'm going to do 3y minus 7 equals 3x plus 2xy. Factorize out x. Okay, and finally we're going to get x is equal to 3y minus 7 over 3 plus 2y. Okay. Again, let's delete. Go back in the video if you're not sure. Okay, G, you've got to do a little trick here. The first thing you need to do is take the 1 away. Y minus 1 equals 2 over x minus 3. Okay. Then get that x out the denominator. So you're going to get x minus 3 times y minus 1 equals 2. Now expand, you'll get xy minus x minus 3y plus 3 equals 2. So anything that doesn't have an x in it, get it over to the other side. So you're going to get xy minus x equals 3y minus 1. Okay, that's just taking this part over to the other side. Factor. I'm going to get x times y minus 1 equals 3y minus 1. So x equals 3y minus 1 over y minus 1. Okay, and the last one is very similar. Get rid of that negative 2, so it'll be y plus 2 equals 5 over x plus 4. Get the x out of the denominator. X plus 4 times y plus 2 equals 5. So xy plus 2x plus 4y plus 8 equals 5. So xy plus 2x equals negative 4y minus 3. Factor out x. And finally divide by y plus 2. X equals minus 4y minus 3 over y plus 2. Okay, and there are your solutions. Now, last bit of work. What about in context? Okay, so here is a sort of real life question involving rearrangement of formula. So stop the video and have a go. You need to remind yourself a little bit about standard form as well. You can use a calculator to help you. So have a go and see what you come up with. Okay, so first of all, this is a formula created by Einstein. The gravitational force between objects is given by the gravitational force is equal to gravitational constant, universal gravitational constant. That's just a fixed number. It's always the same. Times the mass of one object times the mass of another object divided by the square of the distance between the centres of those two objects. Okay, that's all that it's telling you. We don't really need to understand it. All we need to do is put the right stuff into the formula. So it says the Earth has that mass, the Moon has that mass. Given that the Earth and Moon are this distance apart, find the gravitational force between them. So the gravitational force is equal to the gravitational constant, 6.67 times 10 to the negative 11, times the mass of Earth, 5.97 times 10 to the 24, times the mass of the Moon, 7.35 times 10 to the 22, divided by the distance between them squared. 3.82 times 10 to the 8 squared means times it by itself. Okay? And so just remember, all you need to do when you're doing standard form is you can multiply the numbers together. So there's 6.67 times 5.97 times 7.35 equals 292.6, let's go 68, 2 decimal places, times 10 to the power of, all we need to do is add up the indices, 24 plus 22 minus 11 to the power of 35, divided by a 3.82 squared is 14.59 times 10 to the power of 16. Okay, so now I can do just going to go up here and do it. Division of the numbers, 292.68 divided by 14.59 equals 20.06 times 10 to the power of 35 minus 16 is 19. 10 to the power of 19. Now you'll notice that's not standard form. So it should actually be 2, I think it's going to be about 2 times 10 to the 18. Okay, so that's the gravitational force between the Earth and the Moon. We just delete that. So a little bit of reminder about standard form there. Done lots of work on standard form. Okay, now it says rearrange the formula so that D is the subject. I'm just going to rewrite it so that it's a bit clearer. This just means F is equal to G M1 M2 over D squared. So multiply both sides by D squared. I'll get F D squared equals G M1 M2. D squared is equal to G M1 M2 over F. And so D is equal to the square root of G M1 M2 over F. Okay, and that's the answer to part B. And then it's basically asking you to do two questions where you're using the rearranged formula. So all you've got to do is put the correct numbers into the formula to find out the answer. I'm not going to do that because I don't want to waste time. You can try and do it yourself. And if you've got any doubts, just let me know. Okay? Right.